Okay, we're all set? So you do want to have a calculator. All right, so we just said that these are our two equations that we're going to be using. 3 times 10 to the 8th can be written 3e8 because on our calculator, so I'll kind of show the calculator up here. Remember to type this in. You would type in 3, sorry, and then you would hit the blue button up here, the second, and then here's the x to the -1, EE, and so you should have an E show up on your screen. And then you would type in 8. If you push enter, that'll give you your answer, or not your answer, but your number written right there. Real quick, hit second DRG, and you can switch between flow and science. So that means kind of the normal versus scientific notation. Okay, so you can see now how big that number is, right? It kind of put it in perspective for you. But you already knew that because it was a positive exponent, right? Positive exponents mean big number. Okay, all right. Can you guys see it okay? You guys doing okay? No, can't. I think so. I'll put it on this side. Let's see if I can on this side. I don't know. All right, so we'll leave it right there. All right, so 3e8. So your calculator help, if you wanted to write down some instructions, what we did was we typed in the 3. We hit the blue second button. Then we hit the x to the -1, which has a little EE on top. And then we hit 8, and then we pushed equals. Remember, the reason that I want you guys to use this E button is because when you go to do your multiplication and division and things like that, this allows you to not have to use parentheses, okay? Which is going to be super helpful this school year. All right, the other calculator help that was to switch between regular versus scientific, what we hit was I'm going to write it on this side. I'm going to say second DRG, and then you kind of toggle between flow or psi. So scientific notation is the one with the exponents, right, times 10 to the something. Flow will include all of your zeros. Sometimes if you have too many zeros, it forces you to have to use scientific anyway. You don't have that choice, okay? So if you run out of room, it's going to put it in scientific no matter what, okay? All right, are there any questions on these two little calculator helps? We all good? 8? Oh, it says second. This is the button that you had to push, the x to the -1, because there's a little EE on top of it, if you look at your calculator. Okay. All right, we know that lambda, the upside down y, is what? Wavelength, right? All right, so wavelength. We are not just going to focus on, so that one quiz question that you guys had to try, you guys did okay. Some of you guys got them all right, which was really cool. So, so wavelength, okay, the fact that it's a length means that the units, so this is a variable, these are variables over here. The units are the part that comes after the number, right? So units come after. I'll just circle them. But wavelength, we're going to have meters. That's your SI unit, meaning that's the unit that you want to be in for most of your calculations to use your constants. And I will say, in order to use this constant, we have to be in meters, which is why the stuff that you put in your data table, can't use it yet. Okay? All right. F is for frequency. So the variable is an F. The units can be Hz, or it can be 1/second, or per second, because you're saying how many events happen per second. Okay? So one or the other. All right, cool. Now to fill out our little triangle, you always put the ones that are being multiplied, you leave them next to each other. So you can always make a triangle for all of your equations that you ever use, right? So the stuff that's being multiplied, you leave on the bottom because they're next to each other on the triangle. So we put our little lambda and our frequency, and we would put C on top. Okay? Again, how to use the triangle. If I say you're solving for, like for example, in the first problem, it says, calculate the frequency, blah, 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 blah. If we're solving for frequency, we would cover the F with our finger, and you would be left with C divided by lambda. Okay? So remember, when they're on top of each other, they're going to be divided. When they're next to each other, they're multiplied. All right, our other equation was this E equals HF, right? So E was energy. The unit that you're looking for energy is called a joule. It's a capital J. You will see kilojoules a lot this year. Okay, that just means that it's 1,000 joules. Okay. Yeah. All right. And then we have our H. This is Planck's constant or Planck's constant. Same place where you found your speed of light. It's also on the inside. So if you open up your little periodic table that was given to you, you have H, Planck's constant, 6.63 times 10 to the negative 34 joules times second. Okay? Sorry. All right. So 6.63 times 10 to the negative 34, and the units for this is joules second. Okay? Now, this does not mean you multiply anything. This is a unit. Biggest problem people do is they look at that and they're like, oh, how do I find this? How do I find M and S, right? So don't do that. Those are units. Just leave them alone. They define your number, all right? It's instead of saying 6.63 elephants, right? We have to tell them what we're talking about. All right, so H is that. F, once again, is frequency. And again, it can be hertz or it can be events per second. So we put 1 over second. Either one of those, okay? So the common thing that both of these equations have, which is kind of your bridge between the two equations, is obviously going to be your frequency, right? So you can always do 2 steps, or if you look at the back of your periodic table where you have your equations, these were what you looked at that science station, right? Here's our first equation that we just talked about. So if you ever forget them, they're right here. You don't have to memorize them, all right? Energy, Planck's constant times frequency. And if you ever need to do energy, but you're given wavelength, you could have either solved for frequency and then plugged in, or you could just use the big, long equation, all right? You can use either one, but it's all on the back of the periodic table for you, okay? All right, so when you go to type this one into the calculator, because I do want to help you with that one, right? This little, I'll put it over here. Where you would type in 6.63, you would hit that second EE, and then you would just hit negative 34. Okay? If you get an error message, most likely you hit the minus button instead of the negative. The negative is the one down at the very bottom. Minus is over here. So make sure you use the negative. If you're using Google Calculator, they use them the same way. So you can also do it online. They also have an E button. Okay? All right. The unit for wavelength must be in, what did I just say? What does wavelength have to be in? Meters. Meters, good. What is the unit for frequency? Hertz, or 1 over S, which means it has to be per second. That's what's important to you, the time part, right? Per second. If it's in per minute, you got to change it. All right. What is the unit for energy? Joules. All right. So the first equation the first question we have, actually so far, are there any questions on this? I guess we can fill in this over here. Put your E on top, H and F go on the bottom. You're going to use it the same exact way. Okay? Were there any questions on the setups or the variables? All good? All right, cool. All right, so the first example says calculate the frequency of yellow light. So cool. So we know that that's associated with a number now that we've done the flame test lab. Okay, we're going to calculate frequency, and we're given a wavelength of 4.2 times 10 to the negative 7 meters. So I usually have you guys get in the habit of circling who you're solving for, underlining what you're given, right? Or vice versa, okay? But knowing what information is there, okay? So Because then I would turn around and say, okay, well, what is this variable? I know frequency is f, so I would put an f right there. I know wavelength is upside down y or lambda. So now I see both of those. What this tells you is which equation we're stuck with, right? Which is the only equation that has lambda. The one with speed of light, right? That's the only equation that you can use. You can't plug into this. Do you see that? You don't have the right variables. Okay? So first you got to decide which one you're using. So now that we've decided we're going to be using this one with the speed of light, we can go ahead and set ourselves up. So we know that speed of light is going to be lambda times frequency, but we're calculating for frequency. So we're going to go up here, we're going to cover frequency. It's going to be speed of light divided by lambda. So I'm going to write my equation just so my lambda is wavelength. It's instead of me saying upside down y. It's a Greek letter. Excuse me. All right. So speed of light divided by lambda. Now we're going to plug in. So we're going to have 3e8 on top, or 3 times 10 to the 8th, divided by, and then whoever we had for wavelength. So this would be 4.2 e, and then you put your little exponent, -7. Okay. So when we go to type this in, this is the part where I say you don't have to worry about parentheses because we're using that e. If you're trying to type in times 10 to the, sometimes it confuses the calculator, so you don't necessarily want to do that. All right, so I'm going to type this in. I'm going to go ahead and say 3, the second, e, and we got 8. Then I'm going to move right into divide 4.2, hit that e again, and then -7. Okay? So that's what I have on my calculator. Notice no parentheses, nothing. You don't have to worry about it. When you're ready, you're going to push enter, and we get our answer. So biggest question you guys always ask, how many decimal places do I go to, right? Which is fair. We didn't learn significant figures. So what I always, my rule, you don't listen to the decimals from the constants. You listen to the decimals from your problem, okay? That's the easiest way to do it. It's not necessarily following significant figure rules, which don't worry about it if you have no idea what I'm talking about for there. So up here, we went to 1 decimal place. That's what we're going to go to, okay? That's safe. Technically, we would go to 2 significant figures, but we'll save that for another day. All right, so to write our answer, we would say 7.1, but you have to include that last part. What does it say on your calculator? It says times 10 to the what? 14, yeah? Times 10 to the 14. If you want to report your answer 7.1E14, that's fine. But there's something missing from both of those answers. What am I missing? Your unit. Who are we talking about, right? So we are talking about frequency, so you can end with hertz, or you can say 1/2. It doesn't matter. Okay? Make sure you put those units on there. This kind of gets overwhelming when you're looking at numbers, so you might stick with hertz. All right, is there any questions on that one? Okay, let's do another example. So this one says calculate the energy, so I'm going to circle the word energy, of a photon with a frequency of, so we have a frequency now of that. So I know that we have E and we have F involved. Which equation are we going to be using? The right one. Not the wrong one. No, this one over here. That's good. Yep. So we're going to be using the one that had Planck's constant in it. So we're going to look at what we're solving for. We're solving for energy, which means if you cover this up, you're doing just the straightforward equation, which is H times F. So we're just going to write that out so we know what we're trying to do. We're going to say H, which was 6.63 E -34. And we're going to multiply that by frequency, which was 4.60 times 10 to the 14. How many decimal places do you want to report your answer to? Probably 2, okay? So let's look at our answer. Let's try typing that one in. That's a beast. So I will put the calculator right here so you can kind of see which buttons I'm pushing, but I'm just following this along, okay? So I'm going to say 6.63 E negative 34. Then I'm going to push multiply. And I'm going to say 4.60 E 14. So again, no parentheses. We're good. We're going to push equals, and that's what we get, okay? So we're going to go to 2 decimal places is what we decided. So we're going to go ahead and say 3.0, should we do 4 or 5? 5. We were going to round up because we look at the guy behind it, okay? So 3.05 times 10 to the negative 19 is going to be your answer. And what's the units that we're going to put? Joules. We're going to put a J. How does that feel? Good? Okay, awesome. So I'm going to go ahead and stop the recording. I'm going to give you guys a minute to kind of let that sink in and practice, and then we will look at our lab for a second.